Hey, what is up guys? Welcome back to another video, and in this video we're going to be continuing on with our C# programming tutorial series, and in this particular tutorial we are going to be taking a look at how we can create a generic interface in C#. So, let's get started here. The first thing we want to do is we want to create a new interface. So let's go ahead, go into our Solution Explorer. Go ahead and right-click on your project. Add class, like that. Okay. Now, let's go ahead and select Interface, and we'll call this iCustom Collection. Alright. Now, one thing I should mention before we begin is that in our custom collection, I have removed a couple things. I have removed our add method, our remove method, as well as our remove at method, and our indexer. One thing I want to do is we're going to go into Chrome, and we are going to look at the documentation for how we can create an indexer inside of an interface. Because I want to show you exactly I want to show you the process of how exactly we can go about looking these sorts of things up. So let's go ahead and do that real quick. Now that we have our interface. So we'll say Chrome, C# indexer inside interface, like that. Alright. Skip to main content. You can see we have indexers inside of interfaces for our C# language guide. That's exactly what we want. So go ahead and go to that. Let's go ahead and browse this article until we find what we're looking for here. We want an example here. Okay. Alright. Okay, so we have a interface, index interface. And so we have int this index. Okay, so you can see in this example, it looks very similar to how we would have done it in our actual class here, but we're not providing a get and set implementation inside of our interface, similar to what we would do for a property in an interface. So let's go back into Visual Studio now that we are equipped with this new knowledge. And we will get rid of any unused imports. I'm going to change this to a file scoped namespace. And we're going to change this to public. Alright, so inside of our little custom collection interface here, we're going to first have a property, and that is going to be for the count. So we'll say int count get. And so there's our property. Now, whenever we implement this interface, we will have to provide an implementation for this property. The next thing that we can do is we'll go ahead and do our indexer. So we can say, well, before we do our indexer, we need to make this interface generic. So where we have declared our interface, public interface iCustomCollection, I want you to do a less than t greater than. So we have our generic type parameter t here. Now, whenever we use this interface, it's going to be interpreted by C# that this is a generic interface and that we must provide a type parameter. Okay? Now, let's go ahead and create our indexer. We want t is our return type. This int index. And then we want get set like that. All right. And there is our indexer. Relatively simple. All right, so now what we're gonna do, okay, looks like we have a bit of a issue here, so let's try to change that. There we go. That works. All right, next, let's do our methods. So we'll say void add t item, void remove t item. We'll say t remove at int index, void clear okay, and then we will have our then what we will do is we will also have a void sort like that. Okay. So now that we have our interface created here, let's go back into our shape list. And inside of our shape list, before or after IEnumerable, I'm going to do it before IEnumerable. We can implement the iCustomCollection t interface. Now you can see we're using the generic type t that we're using for our class here as well inside of this interface, and we're separating our two interfaces that we're implementing by a comma. So once that's done and we can save it, let's go ahead and do a control period. And we want to implement this interface. Perfect. Now let's go ahead and implement these required properties, indexer, and methods. All right. All right, so first let's go ahead and do our indexer. Public T, this index. Okay, let's get rid of our getter and setter here. We'll implement that ourselves. And we will do that. Alright. So what we'll do now is we'll have our get, which will be if index is less than 0 or index is greater than count minus 1. We'll throw a new index out of range exception. Otherwise, we are going to return this dot underscore data and our index there, like that. Here we'll have a set if index is less than 0 or index is greater than count minus 1. We want to throw a new index out of range exception. Then we will say this dot data index equals value, just like that. All right. Make sure that that's all squared away. Okay, it should be okay. We'll fix it if we need to. All right. So next is our count. We'll say instead of throwing a new not implemented exception, we will say this dot underscore data dot count, just like that. Okay. Now we have our property implemented as well as our indexer. Okay, public void add. Okay. This dot data dot add item, much like that. Now public void clear. Let's say this.data.clear. For once, Visual Studio is actually giving me useful suggestions. And now the next ones, there it is, public void remove. This.data.remove, and with our item. Now public t remove at. We will say t item to remove equals this not data at our index, or rather, in fact, we should make this a little bit more robust and say if index is less than 0 or index is greater than count minus 1, we will throw an argument exception. The provided index is not a valid index. Okay. Now, after that, we can say int, let's call, or not so much even an int. Let's call it t temp equals this dot underscore data at our index. And then we can do our this dot underscore data dot remove at our index, and then return temp like that. All right, let's do a quick sanity check. Okay, we have, it says invalid token, so what do we got? Ah. Maybe it's just that extra semicolon that I accidentally put in there. So let's save that. Again, do another sanity check. Okay, that's 5001. We don't need to worry about that. Okay. 1955. Ah, I see what I did wrong here. we want to throw a new argument exception. We don't want to invoke argument exception like it's a method because it's not a method. Okay, we should be good now. Okay, we're all good now. We got all of our methods, properties, and indexer implemented. If we save this and we go back to Program CS, we can go ahead and create a bunch of cubes using a method here. And this will say shape list cube fill with random cubes int number of cubes Alright, we will then have our random object equals a new random, and then we'll have shape list cube list equals new shape list of cube, like that. Then we will do a for int I equals 0. I is less than number of cubes I plus plus. We can say cube C equals a new cube double, and we'll say random dot next. We'll make that a random number between 1 and 10. And so there we go. Now that we have our cube, we can list.add C. Just like that. All right. Now, what we can do is we will then, above our method, or rather, we haven't even returned our list yet. Return list. There we go. That's better. Let's go ahead and we'll say shape list cube list equals fill with random cubes. We'll say 20 cubes, like that. There we go. We can then go ahead and for each cube C in cubes we will say console write line C dot, let's say, calculate surface area, like that. Well, we'll go ahead and print out the surface area of every cube. Let's do a sanity check to make sure we don't have any errors. Okay, 0103. Let's save that again. Make sure we don't have any errors. I see. It should be list, not cubes. There we go. Okay, let's save that. Okay, we have another error. Okay, let's try that. Now, we should be okay now. Okay. We don't have any more errors. We're good. Let's go ahead and we're going to go ahead and do our Control F5. Let it do its thing. And there we go. You can see we have all of our stuff in the debug console. Let's go into our command prompt and we'll do a .NET run as well. And there you go. Now you might be wondering too, why did I leave the sort method unimplemented? Well, I want you guys to figure out how to do that on your own. It should be a relatively simple task, but I want you to figure that one out on your own. But that pretty much does it for this video on generic interfaces. Thank you all so very much for watching, and we'll see you in the next one.